The product used for this product case study for ME110 is the Tanita BF-682W body fat scale. Team members are Darren, Norland, Tom, and Benjamin. The top left picture displays all internal components of the body fat scale. The three pictures to the right are the injection molded and hot stamped shells that keeps the scale together. The manufacturing process on this printed circuit board, otherwise known as PCB, is reflow paste soldering. The evidence of this process can be found in how the solder is uniform throughout the board, suggesting the use of solder paste. There are integrated circuits on the board, which requires surface mount technology and through-hole technology. This board is therefore not a pure through-hole board, so reflow paste soldering must have been used. The alternative process for this could have been wave soldering. Evidence of this is the defected pin that clearly shows poor wetting on the surface of the component, as shown in the red highlight. The components are also all soldered on one side of the board. However, reflow soldering is more advantageous for a smaller number of connections. For example, it takes 200 to 300 connections versus 1,000 connections from wave soldering techniques. Through-hole reflow soldering eliminates wave soldering as a step. Therefore, it is cheaper, making it the more cost-efficient option. In the manufacturing process for the plastic casing, injection molding is the best choice for this part because of its complex shape, singular piece, high production rate, and thin walls. We can also see where the ejector pins pushed apart out of the mold as evidence of injection molding. The alternative process could be transfer molding. Evidence for this includes suitable for encapsulating microelectrical devices, such as the PCB. May be more expensive since it produces near flashless parts and one preform that can fill hundreds of cavities in a short amount of time. It also requires shorter cycle times, tighter tolerances, and can make more intricate parts, making it more consistent than other processes. The manufacturing process of the metal bracket is hot stamping. The bracket was heated up and then stamped. The discoloration is due to heat applied, and it is necessary because of the tough metal. Alternative processes could have been 2D cutting operations, such as water jet, laser, or plasma cutting. But due to high cost of these processes, it might not be an attractive choice for mass production of parts. The frame consists of the base plate and its bended walls. We believe the base plate was heat stamped with a progressive die, then parts were flanged to walls, which is evident in the shape and form of the frame. Stamping includes a wide variety of operations with a low labor cost. Bended and flanged walls are also evident in the highlighted bends on the picture to the right. Ridges were added during the stamping for strength. A possible alternative process is transfer die stamping. It is similar to hot stamping as it features cutouts, pierced holes, and threading. It is better for mass production to use transfer die stamping's regular press operations that utilizes different stations, resulting in a cheaper process. However, hot stamping with a progressive die is the preferred method for higher production rates. GD&T is essential for successful joining between two parts. In the case of the main weight scale shell and the foot mounts as shown, the size of the main case's holes as highlighted in red must fit inside the specified tolerance zones on the foot mount. Otherwise, the foot mount will not mate with its overall case. Size is important because the sensors connected to the foot mounts can't give an accurate reading to the scale if they do not fit. Thank you.